Hi there, my name is Jeff Beers with the Yoda Guy. Today I am working on a project located just off the camera. Is a 1989 Toyota Land Cruiser. It's a Land Cruiser Troopy, and the vehicle was actually imported from an eastern country. I believe it was Dubai, I want to say. The VIN tag is in Arabic, so it kind of gives it away. One thing is that the Troopy was not available in the United States for sale. To get a new vehicle, it's still not considered legal to import those vehicles here unless they're past the vintage laws, which is like 26 years or older. So that's why we have a 1989 here, because it totally passes those laws. One thing about it though is that the Troopy comes with a 3FE engine. It's basically an inline six-cylinder that is kind of like an industrial power plant, if you want to call it that. Doesn't make a whole lot of horsepower, makes an okay amount of torque, pretty reliable, but for here in the States, it's kind of hard for highway driving and things like that, and you're not really going anywhere in a hurry. So we wanted to try to figure out an engine platform that we wanted to use in this, and so we discussed lots of options of what we wanted to use. The one that stuck out the most was an early edition of the 1989 to 94 1UZ-FE. Now it's a Toyota 4-liter V8. We wanted to use a Toyota V8 to kind of keep the authenticity of the Toyota platform. So, you know, we could have dropped in an LS motor in here, which a lot of people have done, or a small block 350, all that stuff, but we decided to do a Toyota version. If you know anything about the 1UZ-FE, it is a very renowned engine for performance. Now, not many people realize its performance capabilities that it can possibly have to it. Now, out of the gate, it's like the non-VVTi version, I believe, is about 245 horsepower in similar torque in that range. So, over the stock platform from what the 3F is, that's a pretty significant increase. And you know, it likes to wrap out at a lot higher revs as well. The big thing about this engine is its strength. Now, the strength where this engine gets its, you know, beefiness from is from the 6-bolt mains that it has. The mains are basically what holds the crankshaft in place. So there, I have the crankshaft here. This is pre-cleaned. I haven't cleaned this off yet, so it looks a little dirty. But these connecting rods, they basically have 6 places, mounting holes on the engine block. So I have the engine block right here. I've all had it professionally cleaned and everything like that. So we got a lot of clean metal here. So as you can see, inside here, that's where the 6-bolt main would go. There's these 4 studs right there, and then there's 2 bolt holes that come off to the sides. Now, technically speaking, strength-wise, 6-bolt mains, awesome. That's like where your big power can come from. And the other thing, where another weak link that a lot of engines have, is their connecting rods. The connecting rods on these, on the first edition, basically right here on the thickness, they're extremely thick on the 1UZ-FE. And they pretty much overbuilt the crap out of this V8 engine, because I believe Toyota had wanted to try to almost create a race platform to enter into some, you know, international car races, and needed a vehicle to use it as a platform. Now, I don't think that platform really went anywhere, because all they did is put it in, you know, sedans and coupes and stuff like that. So basically, if you're aware of the 2JZ out of the Toyota Supra, imagine a V8 version of a 2JZ, and that's pretty much what you're going to get with the 1UZ-FE. The early editions, the VVTi ones, they have thinner connecting rods, and I believe they only have 4-bolt mains. So the reason why the strength there is so important is not for a naturally aspirated setup. What we'd be looking at for strength-wise is for boost. When you start adding boost, like throwing turbos and throwing superchargers on there, and you're cranking out a whole lot of power, things sometimes are put under too many stresses that they can't hang on, and you basically can grenade the engine. Grenade basically means catastrophic failure, connecting rods snap, the crankshaft breaks the engine block and shoots out the bottom of the engine, and bad things happen, and it's totally wrecked. So this crankshaft is good for well over 700 horsepower. These connecting rods are also good for over 700 horsepower as well. The biggest weak link though on the stock engine block on these are the cylinder head bolts and the head gaskets. So usually when you take an engine like this, so this one had about 200,000 miles on this engine, so we wanted to do a complete refresh. So it's getting all new bearings, and we're going to completely measure out a bunch of things and make sure everything's into spec and pretty much freshen up the internals on this thing. While we have it apart, we're going to do a couple upgrades. The factory, well, the basic gasket for this that it had was basically a, I don't know if you want to call it a composite material for a head gasket. Now, all the combustion gases are going into the cylinder head here. When this thing fires and you start putting a lot of boost on it, it tends to blow out that composite material because the cylinder head pressures are so great that that head gasket can't contain them. So we're going to go to an MLS gasket, what is called a multi-layered steel gasket. Basically, much more stronger, much more capable of sealing, and it can handle the power. Now, the other thing that needs to be upgraded are the head studs. The original factory head bolts, these little guys right here, they are not known for being able to handle much power. You go above 5, 6, 7 psi of boost, and these things will stretch, break, and when you're doing that on these things, what will happen is the cylinder head will physically lift off from the engine block. It'll just pick right up, and it'll just move along, and you don't want that to happen. So, we are going to be putting in ARP head studs. ARP head studs are basically going to be able to have more clamping force, and they will not stretch, and they will not break for, I don't know, maybe 30 psi of boost, we're thinking. Correct me if I'm wrong, but that's about where I believe it should be. So, now, I know some of the other internals probably can't handle that. I mean, we'd have to probably go to different H-beam rods. We'd have to go to lower compression pistons. But for this setup, what we're planning on doing is building it up, and then if we have time for it, and funds, and parts availability, we might try to throw on a supercharger on here. So, that'll be coming up soon, but we don't know right now, so that's a solid maybe. But while we have the engine apart, we're definitely going to build it up for it so it can handle the power and be ready for the power. So, what I have currently been doing is prepping and cleaning this engine block. One big thing is I have all the pistons laid out here. They were covered in carbon and things like that. Carbon was all up in the rings, the oil rings, inside on top of the pistons. So I cleaned them in a hot tank, pressure washer. I got most of the things off, but I didn't get all the carbon off and everything. Basically, if I can show you, this one's still in the process of being cleaned, but this one right here, you can see a little bit of carbon marks up in these little valve relief grooves. There's little black spots, a little bit of carbon left there that we're going to be trying to remove. This one, though, looks like it's pretty much cleaned off. That's what we're kind of shooting for all the pistons to look like. So they basically look brand new. While we're doing the inspection, got these things labeled. While we're doing the inspection, we want to double check everything. One thing that we want to check is the cylinder bores. Now, with having 200,000 miles on it, we are curious on how this engine has been running. So first things you usually want to do is check inside the cylinder bores. If you can still see the factory cross-hatching, cross-hatching is basically where they kind of hone the cylinder bores, and it's meant to kind of allow oil to build up on the cylinder walls and be cleaned and stuff like that. That is also a good indication of wear on an engine block. This engine pretty much has majority of its cross-hatching